Good day everyone. Today I will be introducing the core concept of our project, which is focused on a GCPV system or grid connected photovoltaic system. Essentially, this is the solar power technology that operates in direct synchronization with the local utility grid. Unlike a standalone system, a GCPV system does not operate in isolation. The solar panel captures sunlight and converts it into the DC electricity, which is then it inverts to the AC power. This power is integrated directly into the building electrical network and work seamlessly alongside the grid supply. Now, the main highlight of GCPV configuration is that it does not require expensive battery bank. Battery storage often introduce high initial costs, heavy maintenance, and efficiency losses. Instead, the utility grid itself acts as a virtual backup during the peak sunlight hours. Any excess energy generated by our system is fed back into the grid, often utilized under mechanism like an NEM or net energy metering. Conversely, at night or during the low irradiance, power is automatically drawn back from the grid. This makes the GCPV setup highly efficient, cost-effective, and sustainable. It directly addresses modern energy challenge by lowering the utility bills and reduce overall carbon footprint. That concludes my part, and I will now hand over to the next presenter.
Hello everyone, I want to show you how a grid connected solar system works. If you look at this diagram, you can see that the energy flow in a very simple, step-by-step path from the sun all the way to our homes and the power grid. First, let's look at the solar PV array. These are the solar panels on the roof. Their job is simple. They catch sunlight and turn into DC electricity. But our whole appliances cannot use DC power, so the energy goes to the inverter. Think of the inverter as a translator. It changes the DC electricity into AC electricity, which is the exact type of power our homes and local grid need. Next, this usable AC power goes into the distribution board or distribution panel. This acts like a traffic cop for electricity. It automatically sends the solar power output to AC loads. This means your lights, refrigerator, and air conditioner run on clean, free solar energy during the day. But what happens if your panel makes more electricity than your home needs? This is the best part of grid connected system. The extra electricity flows downward into the electricity utility grid. By directional or smart meter, measure this. It tracks how much power you take from the grid at night and how much extra solar power you give back during the day. When you give power back, you get credit to lower your electricity bills.
For my part, I will explain the day and night operation of a grid-connected photovoltaic system. It's called GCPV. During the daytime, the solar PV panels receive sunlight and convert solar energy into DC electricity. However, most household appliances use AC electricity, so the inverter is needed to convert DC electricity into AC electricity. After that, the electricity can be supplied to the building load, such as lights, fans, and other electrical appliances. In a GCPV system, the building will use the solar power first. This helps to reduce the amount of electricity taken from the utility grid, so it can help lower the electricity bill. When the solar panels produce more electricity than the building needs, the excess electricity will be exported to the grid through the meter. At night, there is no sunlight, so the PV panels produce little or no electricity. Because of this, the building will automatically draw electricity from the utility grid. This allows the electricity supply to remain stable even when solar power is unavailable. Conclusion: GCPV works by using solar power during the day and relying on the grid at night. This makes the system practical, reliable, and suitable for homes and buildings. Thank you.
I would like to present about the benefit and financial scheme of CGPV in Malaysia. The first benefit of CGTPV is reducing electricity bills. Solar panel generate electricity from sunlight, so user can reduce the amount of electricity purchased from the grid. The second benefit is environmental sustainability. Solar energy is renewable and clean energy source because it does not produce harmful gas emission during operation. Besides that, CGPV system also have low operating and maintenance costs. Solar panel can operate for around 20 to 25 years with minimal maintenance. Another benefit is energy independence. User become less dependent on conventional electricity supply and less affected by increasing electricity tariff. Now, I will explain the financial scheme applied in Malaysia. The main scheme used in Malaysia is Net Energy Metering or NEM. This scheme is implemented by Tenaga Nasional Berhad and Sustainable Energy Development Authority. Under the NEM scheme, electricity generated by solar panel is first used by the consumer. If there is excess electricity, it will be exported to the utility grid. The exported electricity become credit and can offset future electricity consumption. There are several types of NEM scheme in Malaysia. First, NEM Rakyat for residential users, NEM Government for government buildings, and NOVA for commercial and industrial sector. Besides NEM, Malaysia also previously used the Feed-in Tarif or FIT scheme. Under FIT, users can sell solar electricity to utility company at a fixed rate. In conclusion, CGPV system provide many advantages such as reducing electricity costs, supporting green energy, and reducing carbon emission. Among all financial schemes, Net Energy Metering or NEM is the most widely used scheme in Malaysia today. Thank you.
For summary of this slide, we can conclude that the GCPV, Grid Connected Photovoltaic system are a cost-effective and sustainable energy solution for both residential and commercial building. The second summary is we can conclude that solar energy helps reduce the electricity bills by generating the clean energy directly from sunlight. And the third one is the GCPV system requires low maintenance and have a long operational lifespan, typically 20 to 30 years. If we look at the future trends of the solar GCPV, the first one is solar energy adoption is rapidly increasing worldwide due to growing demand for renewable and sustainable energy resources. The second one is the advancement in solar panel technology are improving efficiency while reducing the installation and maintenance loss. And the last future trends that we can see that the solar system are expected to become a standard feature in future residential and commercial building designs. That's all from me.